Today we start a completely new section on our channel and it is devoted to physics. I will try to keep the customary style of the Assignment Experts channel. My name is Irene, same as our math tutor's name, and I will try to explain things seeming complicated in a very brief and clear manner. Of course, we will have lectures to understand theoretical background and much practice solving the most popular problems that may occur in your homework. So, today our talk will be devoted to one of the main notions in physics – energy. Despite this thing is very important and fundamental thing to understand, even if you are not a physicist at all, many rumors about it do exist, like about anything else important in our lives. Traditionally, physics courses define energy as the ability to perform work. But then, what does the word work stand for? Sometimes it is proclaimed that energy is what can be transformed into heat, herewith involving the new concept named heat. However, this doesn't add up to our understanding still, because later you may hear statements like work can be transformed into heat, or to define heat we need to talk of internal energy of the system. Moreover, many students refer to a body as to possessing heat. Surely it is confusing and seems to be something devised to fool you up. Further today, we will see that many of those definitions are in fact equivalent, and it is the only manner of speech which one to use for a particular situation. However, there are many rumors or simply ineffectual definitions among them as well. To make situation clear, we've shot this video for you. So, talking about energy, I will insist you need to remember only the following. Energy is the measure of ability to move. Now you have one and only definition for all the cases. So, when you say that object possesses energy, it means it moves right now or has certain stored ability to do that. The part of energy which is not currently represented as motion but stays in the form of ability to move is called the potential energy, while the part corresponding to the motion occurring right now is called kinetic energy. This thing is so fundamental and important that helps to answer hard questions in a very simple way regardless of the size system has, being it very large, for example stars and galaxies, or very small, for example, elementary particles studied at colliders. To understand this, we'll look at some examples. Consider the first one. Suppose you are playing ping pong. So here's the table, here's the net, here's the racket, and here's the ball. And when you strike the ball, it moves somehow. You see the motion, and motion is occurring right now. So the energy corresponding to this motion is called kinetic energy. Suppose you face another situation. Your tennis ball is tied to a ceiling and hangs freely. There is no visible motion of the ball. But due to the fact we are all living on Earth, which generates some gravity, the ball has potential energy, which can be transformed into some motion if we cut the thread. Actually, almost every academic course regards energy to be a scalar, not a vector, which means energy has no direction but only a value. In other words, they state that it doesn't matter for energy at all whether the body moves or wherever to generate motion. You may feel now that is something weird in this statement, and surely you do. Okay, we cannot say anything for sure how a driver will prefer to use the full tank of his car or whereabout he'll prefer to drive, but when he travels, we know the direction definitely. Therefore, the kinetic energy seems to have the direction, like to be a vector, while the potential energy, being the stored part, can really be a scalar. But this is wrong despite intuition may protest, and we'll discuss later why. It will play the prominent role in special and general relativity, but now requires new definitions and notions which may be confusing a little bit. Now we move to another interesting point of our talk. It happens so that people's vision has certain bounds. We can't see very small objects, so the complete internal structure is hidden from our vision. That's why we need telescopes, microscopes, colliders, and other resolving devices. Most objects in nature are composite, which means they have internal structure, actually parts. Nowadays, it is verified that such division ends up with elementary particles, being the tiniest part of any substance. Moreover, they move all the time very, very fast and form bigger parts called atoms. Also, atoms move very, very rapidly. Consider, for example, gases. The atoms they are composed of move quite rapidly and quietly free, because atoms are far from each other. Liquids have more bounded atoms, while solid substances have atoms which are closely tied together. Nevertheless, even in solids, atoms vibrate very intensively. We do not see those myriads of movements, but we can feel them as well as our measuring devices. Such movements can be felt as some temperature objects have. You may take your teacup and burn your fingers off. That is because the molecules your teacup is composed of move very fast and strike your skin, mostly damaging it. This may sound weird, but that is exactly how it works. For many centuries, people didn't know that the temperature that objects have just expresses the average kinetic energy of their microscopic constituents. Nevertheless, they observed how hot objects contacted cold ones, making them warmer. This observation resulted in the introduction of the word heat, and this word stands for the regular energy transfer between any two objects with different temperatures. Consider the situation. Here you have the first object with a temperature say T1 and the second object with a temperature say T2. They contact across some boundary. Here it is. The regular energy transfer across this boundary takes place. This energy transfer is called heat. Nowadays, it is obvious that heat is not a particular and outstanding notion, but just another word to represent the regular energy transfer between any two systems with different temperature. The only important thing to understand about this is that this energy transfer is carried out by some mechanism not clearly visible with our eyes, because it happens on the microscopic level. Here, the fantastic number of atoms of the first body strike fantastic number of atoms of the second body, transferring their kinetic energy, their motion. By the way, microscopic constituents of the object can have their potential energy as well. Together, potential energy and kinetic energy of the microscopic constituents of the system are called internal energy. Of course, we cannot feel the potential energy of the microscopic constituents, because it is not a motion, but only a certain stored ability to move. On the other hand, the energy transfer between any two macroscopic objects was given a name work, despite it is very similar to the word heat. Work, just like heat, is the measure of kinetic energy transfer between two objects, and it can be easily measured, measuring motion of the objects involved. Physicists say that work is positive for an object that gains energy, thus motion, and negative for an object that loses energy, doing work. That's simple. Here we see that the word work means just the same thing as we mean while saying word work in our everyday life, mean moving something. Now let us combine all the concepts we've been talking about, work, heat and energy, both kinetic and potential, into one fantastic example. Consider the cup of the hot tea we have here. It tends to go down because of the gravity, and it would definitely go there if I wouldn't support it. The cup has potential energy which can be transformed into motion in some way. While I move it up, the cup gains potential energy. Because the higher I lift it up, with the greater speed it will go down in future when I release it. I won't do that. The cup has kinetic energy as well. I transfer it somehow from my hand while moving it. I do work, I lose energy, transferring it to my cup, and it moves. From the other hand, the cup is hot. That means that the molecules this cup is composed of vibrate more intensely than the molecules my hand is composed of, and thus they transfer energy to my hand. You know now that such energy transfer is called heat. They really hit my hand, strike it, and it even hurts a little bit. Okay, I want to deliver some main points for you today. The first one is the following. Energy is the measure of ability to move. With some caution, you may even say that energy is the motion itself. The second point I want to deliver is the following. Both work and heat are methods of energy transfer between bodies. It is common to distinguish them, but they are too related, just historically used to express energy transfer happening on different scales. Now it should be apparent, while a statement "body possesses heat" is nonsensical. It is analogous to saying "body has work," which you must agree is utter rubbish. Body possesses temperature and body does work are right ones. Similarly, it is incorrect to say that body heat increased. Rather, it is correct to state that body's internal energy increased or its temperature increased. Think of that, ask your questions, or simply enjoy. See you soon. Bye.